processing the game of life with Feminist.AI. Take it away.
Yeah, I can start things off once Christine gets like the screen share going. Perfect.
Right.
Thanks so much, Christine. Yeah, so thank you everyone so much today for attending our Processing the Game of Life workshop hosted by Feminist.AI. I'm Sarah. I use she, her pronouns. I'm 17 years old and a high school senior living in San Francisco. And I've been an intern at Feminist.AI where I've been doing research on TikTok's algorithm and data surveillance. I've also been helping out with being a stage manager for Algorithms of Oppression book club, and also was a speaker on like education under COVID-19 for one of our events. Next slide, please. Here at Feminist.AI, we run critical education programs around algorithms, artificial intelligence, and artificial life. So some of our current programming focuses on algorithmic bias, such as our recent Algorithms of Oppression book club, co-hosted by the Women's Center for Creative Work in collaboration with the Free Black Women's Library in Los Angeles. In this workshop, we'll be exploring the social implications of algorithms through the metaphor of John Conway's Game of Life. Next slide, please. The Game of Life is a logic game represented through an animation of moving cells on a grid, as you can see in this GIF. So in today's workshop, we'll introduce you to the Game of Life and discuss how inequality can affect social outcomes. And we'll provide an animation of the Game of Life implemented as a p5.js sketch, and then we'll create new social and cultural rules for the game that result in new animated patterns using the social design tool poieto. Next slide, please. Yeah, and this is just an example of the Game of Life created using p5.js, and you'll learn how to make this today. Next slide, please. All right. Yeah, so just to give an overview of our schedule, just wrapped up with the introduction, and our next part is that we'll have an intro on the technical approach to the Game of Life using p5.js, and then there'll be a little bit of time for independent work. Then we'll transition to using poieto as a social and cultural approach to the Game of Life, and then again there'll be time for independent work, and we'll close off. So just to reiterate Feminist.AI's mission, Feminist.AI works to put technology into the hands of makers, researchers, thinkers, and learners to amplify unheard voices and create more accessible AI for all. And you can learn more about our mission on our website. And now I'd like to pass it to the rest of our team members to introduce themselves.
Hi, everyone. My name is Hailey. I use she, her pronouns, and I'm coming to you from Vancouver, Canada, on the unceded traditional territories of the Musqueam, Tsleil-Waututh, and Squamish peoples. I'm a member of Feminist.AI, and in terms of just providing a little visual description, I'm an East Asian person with shoulder-length black hair, and I'm wearing dangly pink and green earrings made by my friend Rosemary and a green turtleneck.
Hi, everyone. My name is Nicci, and I use she, her pronouns, and I've been sort of involved in the periphery of Feminist.AI since it was founded a few years ago. And I am coming to you from Seattle, Washington, which is the traditional and unceded territories of the Duwamish people. And I have short black hair, and I'm wearing a black turtleneck today.
Okay, and I am Stephanie Cedeño, and I go by she, her pronouns. I am currently based in Berlin, Germany, where it is 10:10 p.m. right now. What else? I work as an interaction designer and went to school with Nicci and Christine. Was there sort of at the beginning of when Feminist.AI was one of Christine's ideas that is now 4 years out, 5 years out. I can't do math. What it is today, and that's really exciting. And to give you a visual description, my hair is a little bit past my shoulders. I'm wearing a sweater because it's cold, and it's a lavender sweater. And I'm going to pass it off to Christine.
Thanks, Stephanie. I'm Christine Meinders, and it's a pleasure to know all of the Feminist.AI members. I go by pronouns she, her. It's really exciting to have Nicci and Stephanie here, who were part of Feminist.AI at the very beginning, and now our most recent additions, Hailey and Sarah. I'm kind of traveling all over, so it's great to be here. Thank you. All right.
All right, so just to get started on the first part of our workshop, we're going to be doing a technical approach to the game of life, introducing all these concepts, and then going to be playing around in p5.js. Next slide, please. So I'm here to start us all off by talking about the game of life, which is not the same thing as the board game, but has some similarities. The game of life that we'll be talking about today is a cellular automaton that was invented in 1970 by the influential British mathematician John Conway, who I just want to note recently passed away from COVID-19 just this past April. Today's overview of the game of life will be drawing from the book The Nature of Code, as well as the Coding Train YouTube channel, both by Daniel Schiffman, who was one of the instructors of yesterday's workshop. So it's really awesome to kind of be in this like shared space where there are so many great thinkers. And just to start off, a cellular automaton is a model of a system that can be represented by individual cells that live on a grid. So in our diagram in the top right corner here, we can see that we've got a 5x5 grid that is filled with all these individual cells. And also, if I'm going too fast or if something doesn't make sense, feel free to just send anything into the Zoom chat or onto the Discord channel, and I'll try and address it. So in this diagram, all of our cells on the grid here, our cells can be one of two states. Either they can be dead, which we're going to be representing by a 0 in the code and by a white square in our diagrams, or they can be alive, which is represented by a number 1 in the code or a black square in our diagram here. So what we're looking at in the top right corner, the cell in the middle is the only one alive, and all of the other ones are dead. And each of our cells is surrounded by a neighborhood of adjacent cells. And so in our diagram, looking at the black cell in the middle, it's surrounded by 8 neighboring cells as indicated by the thicker black outlines in our diagrams. And so basically in a cellular automaton, we have a set of rules that we can then apply to every single cell in our grid to calculate a given cell's state. And each time that we apply these rules to every single cell in our grid is what we're going to be calling a generation. We evaluate every individual cell according to our rules, and then we can determine whether it's alive or dead. And then after each generation, once we've gone through all of our cells, we get a new state of every single cell based on the previous state as well as its neighbors. So when we apply these rules over and over again, over many generations, sometimes dozens, hundreds, or thousands of generations, it can really allow for patterns of cells switching from alive or dead to emerge. And these patterns can replicate themselves in the grid in predictable and sometimes beautiful ways. Looking at these patterns, we can then analyze the results and think about the behavior of the game of life as a metaphor of moving from being alive to dead. And then we can kind of compare it to the idea of biological production of real cells and evolution, or to artificial life. And so just going to take a sip of water. Again, if anyone has any questions, feel free to message. And so now that we understand what a cellular automaton is, I'm going to move on to specifically working with the game of life and the 4 rules of the game of life. And so as we move through these rules, I just want to encourage everyone to think about the new states of the cell and how our rules that we set limit and determine the types of possible behavior that we can see in our cells. So the first rule of the game of life, the first 2 rules are for cells that are already alive. And I'm going to be talking about how those alive cells can possibly die. The first rule is loneliness, and this is when an alive cell that has less than 2 neighbors, if it has less than 2 neighbors in the next generation, it will die. So if we see in our diagram here on the top row, the cell in the middle that is has kind of the purple outline that I'm using to indicate it, only has one neighbor. So by the rule of loneliness, it will die in the next generation, which we can see to the picture on the right. And our rule number 2 for alive cells is overpopulation. And so naturally, this is kind of the opposite of loneliness, where a cell, if it's alive and it has more than 3 neighbors that are alive, then in the next generation, it will die. And so as we can see in our diagram here, the cell in the middle has, on the bottom row, has 4 different neighbors. That's too many. So by the rule of overpopulation, it will die in the next generation and be represented by a white square or 0. Next slide. And so our third rule for the game of life is coming back to life. And so this is for dead cells. So by our rule of birth, if a dead cell has exactly 3 neighbors in its neighborhood that are alive, then it can come back to life in the next generation of our cells. So by this rule, as we can see in the diagram, the cell in the center has exactly 3 live neighbors. So in the next generation, it can come back to life. Next slide. And finally, our fourth rule to the game of life is something that we're going to be calling stasis, or when cells stay in their same state. So this naturally kind of fills the gap left by our 3 previous rules. So with alive cells, if a cell has 2 or 3 neighbors, then in the next generation, it can stay alive. So as we can see in the diagram in the top row here, the cell in the middle has exactly 2 neighbors. So in the next generation, things don't seem to change, it stays alive. And for dead cells, if it has anything other than 3 neighbors that are alive, then by our rule of stasis that we talked about earlier, this cell will remain dead in the next generation, as we can see in the bottom row of this diagram, that its state doesn't change because it's got more than 3 of our neighbors that are alive. Next slide, please. So noticing the patterns we can see among groups of cells, different patterns can kind of emerge and come along according to our rules. And so scientists have done us the favor of giving these different types of patterns some fun names. So if we could go to the next animation. The first pattern that we're going to be talking about is called a still life. And this little picture here is something that computer scientists are calling a beehive shape. And so a still life is a group of cells in Conway's game of life whose states don't seem to change from one generation to the next. They seem to stay still. So going by our rules, I want everyone to kind of think about why these groups don't appear to change and why still life might appear that way. If you look at this diagram at each individual cell, all of these cells that are alive or black only have 2 or 3 neighbors. So by our rule of stasis that we talked about earlier, they'll stay the same over generations and not appear to change. Next slide. And so the next type of pattern that I want to touch on is what we're calling an oscillator. And so this little picture of looks like 2 squares with the corners flashing on and off is something that's called a beacon. And this is when a group of cells has some cells that seem to stay in kind of the same positions, but the cells switch back and forth being alive or dead. And so if we take our rules here, all of the cells that are alive and are staying the same and not moving by the rule of stasis, they all have exactly 2 or 3 neighbors, so they stay the same over generations. But these 2 cells that are in the middle that are flickering on and off, by following our rules, when these cells are alive, they are surrounded by too many neighbors, more than 3 neighbors. So by the rule of overpopulation, they'll die. But then once these 2 cells die, then they have exactly 3 neighbors. So by our rule of birth or rebirth, then they'll come back to life in the next generation. So over the course of generations, these cells will switch from being alive or dead in kind of predictable ways, which creates this sort of flickering animation effect that we see here. Next slide. And so our final pattern that we're going to be looking at is something that is called a spaceship. And so this type of spaceship that we're looking at is a picture of a glider. And so and also I just want to make sure that if everybody can go to the GitHub document that's posted on Discord, and I'm going to post it into the Zoom chat here, is you can follow along with the slides and sort of see some more examples of different animations. And this document will become useful later on in our workshop. But back to spaceships. Spaceships are a group of cells where over multiple generations, these cells will move from being alive to dead. And so patterns of these cell forms appear to sort of move through the grid in predictable ways. So I kind of want to get everyone to think about how the rules of the game of life that we've been talking about earlier might lead to this type of behavior in the cells. I would encourage everyone to take a look at just one cell in this animation here on the bottom right. Take one cell and then kind of follow it throughout the course of the animation and think about how, according to our rules of the game of life, how that cell might turn on and off, but then how, as a group, then these cells can start to sort of exhibit these sort of replicating cycles and patterns of behavior as we follow our rules over the course of generations. All right, and I'm going to pass it over to Nicci, who will be talking about the game of life with p5.js.
All right, I am going to take over screen share, and I've asked Sai to kindly post this link in the Zoom chat as well, but it should also be accessible through the GitHub link that Hailey just sent. Feminist.AI people, can I get a thumbs up if you can see my screen? Okay, cool. So I will be talking about the p5.js portion of our workshop. And just to give some bit of background on what p5 is, it is a tool for creating graphic and interactive experiences using JavaScript in a web editor. And its predecessor is processing. So P5 follows similar principles that processing and the Processing Foundation has kind of built up. And Feminist.AI will also have a follow-up workshop where participants will be able to work on the same sketch with the downloaded version of the software processing and apply that code to video. So be sure to follow Feminist.AI on social media just to get a sense of when the next workshop will be. And so if you all open the sketch, just to explain this, so this page is structured a little differently than what a typical P5 sketch looks like, in case some of you haven't had experience working with P5 before. So typically here we have the editor and then the preview mode. And in the example sketch that we've shared, the preview is above. So just in case you might want to scroll up and down. And if you want to save the code that you eventually use, you are able to make an account with P5 and open up the editor here, or you can just copy the code somewhere into your notes or a different text editor just to have it on hand. And you'll see here in the example code that we have 3 buttons. One is run, reset, and copy. Copy will allow you to copy the code down here. Reset, or clicking the grid itself, will reset the whole sketch so that all of the changes that you make down here are erased and set back to all the values that you see here. So what we're going to do first is we are going to add a frame rate to this. So as you can see, when we're running this sketch, everything happens kind of quickly, and it's kind of hard to see sort of what Hailey was describing earlier with the different patterns that happen. Although you do see a bit of flickering here, which just shows you how quickly the code is looping through. So what we're going to do here is in the setup function, which kind of dictates the universal rules for this entire sketch, we're essentially going to shape the environment. And so if people want to follow along, or again, if I'm going too fast or you have questions, please drop them into the Zoom chat. So right here, I'm just gonna change the frame rate to, let's do 10. And if I run this again, you'll see that it's moving a lot slower than what it was doing before, and you can kind of have a better sense of how the patterns are moving throughout the board. And so the next thing that we're going to do is change the canvas size, essentially shaping. If we're going to use this neighborhood or spatial metaphor, we're going to shape what the space looks like. And so if I wanted a more square proportion, I would just change this to 400 by 400. This one's the x-axis and this one's the y-axis, if you can follow my screen. So just to give myself some more room to work with, I want to do 600 by 600. And also feel free to just keep changing the values, playing around with each of these as many times as you want. And if you find something you like, you can maybe write it down on the side so you can replicate it again for part 2 of the exercise. And so here we can also see that each cell is kind of big. And if we want to adjust the size, we go to the third line under the setup function with W equals. And you can make this bigger or smaller. I'm going to just shrink it by half of its size. And you can see here that I end up having a lot more cells in this grid. And something that's interesting to think about here too is how you might want to use the size of the canvas and the size of the cells to think about scale and what this means for the different rules that you end up determining with your game of life sketch. And then the last bit is a little more fun, just an aesthetic choice. We are going to go down here in the function draw and change 2 values to try and create a different board that's not just black and white. And so the first line here after the if, we're going to change the fill and change the color of the cells that remain when they're alive. So they're currently black. And processing uses RGB values. And so we're going to be able to have 3 different values that range between 0 to 255. And so what I'm going to do here is I'm going to just guess. I'm not sure what this color is going to be, but if I change those values there, you'll see that all of my black cells now end up being blue. There's also a link in the GitHub document that should take you to a color picker. And if we want, we can pick a different color. Let's go with a different blue. And I can just copy the values from here. And this time what I'm going to do is under else fill, where it currently says 255, which is white, we are going to just drop in, just the numbers, not the RGB part, and change the color of the background of the board. So you can see this is actually very low contrast. And so I might want to tweak this a bit more. Yeah, I'll just go for a random tan yellow color. And I think if we want to, because I can't really see the group, we can also linger here for a few more minutes just to play around with the color values and the different cell sizes until we maybe want to move on to changing the rules of cellular death and production. And the other thing you can do too is if you hit the sketch itself again, you'll see that the animation restarts and plays itself out in different ways. And one thing I like to look at too is you end up seeing different kind of groupings of activities that are happening on the board. And here you can kind of imagine sort of what each area, what story might be for each area here. You can see that like this, for instance, this block of 4 cells, they might look like they're static, but similar to what Hailey was talking about before, patterns that might appear static are probably just shifting on and off. Okay, and so finally, getting to the rules of life. If you scroll all the way down in the code, you will see 4 lines here that correspond to the different rules that Hailey was talking about. So we have loneliness, overpopulation, reproduction or rebirth, and stasis. And the values that we are going to change here are these three values, the 2, 3, and 3. So for instance, with loneliness here, we have a rule that says neighbors die or cells die if they have less than 2 neighbors left. Cells die if they have a greater than three neighbors in their surrounding cells. And then finally, they regenerate if there are equal to 3 neighbors around. So if you shift and change these rules a bit, you can also see different things that might happen. So there, whatever I did just made all of the cells die off really quickly. So feel free to play around a bit more and try to settle on a number combination that works for your sketch. So every time you change the numbers, you'll see really different results, and you can begin to think about what each of these rules mean and how they alter and change the landscape of your board. Hailey, do you have anything to add?
No, not right now. I think it's really cool to be able to look at the sketch from different sizes and from different scales, and it kind of lets you think about pay attention to either the behavior of the entire group or just like a small portion of cells and their neighbors. So I think that that's really cool.
Mm-hmm. And just to go through, if anybody already has an account, you can copy your code into the processing web editor, hit play here, and to produce the same result on the side. This might be an easier way of doing it because then you have the screens side by side rather than scrolling up and down to see what you've been doing. And you can edit the name here. And also save your sketch. Cool. I think we should, I am not able to see, but do we need more time on this or should we move on to part 2?
Thank you, Nicci.
Yeah.
It's always a little strange on Zoom. You can't see people and it's really quiet and it's just lovely to see.
I'm assuming if we don't have any comments or questions, then maybe we can move on to part 2 and just have this tab open so that we can always revisit it.
And also, feel free in chat. I know this was mentioned before, but if you can't find the link, sometimes you just want to go to the rules section and just go to the p5.js game of life example and just change the rules. It's something that's just really fun to play with and pretty simple to do. So if you have any questions, please put them in the chat. All right. So I'm going to go ahead and share my screen.
Mm-hmm.
Okay, I see your screen, Christine. And so I guess, because I can't see the participants either, you guys can still play around with the game of life on p5.js, but this next section or this next part of what we're going to present to you today is taking the same game of life that Nicci and Hailey presented, and not just thinking about it in terms of the game of life as a concept, the way that John Conway sort of mapped things out, and not just thinking about it from the technical point of view, which is what Nicci showed us through the walkthrough with p5.js, but thinking about what the cultural and social approaches and how could be with a game of life. And we're not going to use p5.js for that exactly. We're going to use poieto. So next slide, please. Poieto. This is a funny word, right? But it is a tool that we're going to introduce to you guys today. So what I want to emphasize here is that poieto, the word, comes from the inspiration of sympoiesis, which is a word that means collective creation, essentially, which is what we're doing here today. We're all in a group together. And the second part of poieto also is inspired by the word ethos, which thinks about the character of a community, how you could use art, including music, to influence behaviors. So those two words together are sort of the foundation to what poieto means for us and what poieto as a tool could be. So what does poieto do? Poieto is essentially a software tool, and we use poieto to help design critical technology projects. We, more literally, it actually uses machine learning to perform and connect to other softwares, other machine learning softwares, such as Runway ML, p5.js, like we just did, and also Wekinator. But how does the software work is more interesting, I think. Next slide. I think, yes, exactly. Sorry, I'm going a little too fast. How it actually works is, I think, a little bit more interesting because it really thinks about the social components of technology and puts it into a methodology for you. So we take existing projects or existing ideas or existing concepts like the game of life, and we take the input of this data, and then we think about new frameworks, new frame shifts, and you can think about these frame shifts as new ideas for how we can take something existing and put a new spin on it, thinking about it from a cultural and critical lens. And then we remix it a little bit and have it as output for new projects and creating new AI experiences that we do together as a community. Can you get the next slide, please? So, just get my notes here. I just told you what it did, but what we want to emphasize here is that this has been a community-led project that is currently under development right now, and we're going to go through some mock-ups. And so the first thing that I want to show you, or to give you context to, is that what you're looking at right now is a blueprint, or in design, we call it like a mock-up for what our actual poieto looks like. And so if you go to poieto, you can click on 3 main entry points to either start your own AI project, to create create a new AI project, contribute data, which we can talk about later, and remake an AI project. And so what we're going to do right now in this walkthrough is show you what remaking an AI project could look like. Before we go to the next slide, the example that this mock-up shows is an example of a project called Feminist Search, which was inspired by the book Algorithms of Oppression, as Sarah mentioned at the beginning of this workshop. And in Feminist Search, with Feminist Search, we're just going to remake a project. So if we click remake an AI project, we get to the next screen. And this next screen shows, it's called the blueprint section. And essentially, you're going to take the project Feminist Search, and you're going to see how we can identify what we want to work in this new project. Let me see. Excuse me. Okay, can you go to the slide? This is like, so in the blueprint section, we asked 2 questions. What does the project do, and how does it function? And so we can think about the inputs, the actions, and of the project and the output. So in the project that we just saw with Game of Life, we had a few inputs, definitely looking at the code, and we had a few actions. And we also thought about the actual function of what the Game of Life meant through John Conway's lens. And so we can go in here and add our own inputs, we can add our own actions, and that way we can create our own outputs. And we can basically come up with new rules here. Can you go to the next? The thing about the actions and thinking about our own new rules is that we want to put it in context again to the social critical analysis of technology, basically. And so Poieto uses the term frame shifts a lot. And a frame shift is sort of a lens or a way of seeing something new. And so in this section of Poieto, what we're basically asking people is to identify a few new ways and new perspectives of seeing the technology or the project in front of them. And so in this next section, we were going to ask you to take the Game of Life, the processing sketch that you worked on, the p5.js sketch you worked on, and think of new approaches that you can work on. And I wanted to emphasize here that the cultural and social approach is really important to us because this is where a lot of developers and software developers and those in technology tend to put their opinions and their biases in the design of technology. John Conway was a really good example, I think, to start because he's very simple with what the cellular automata look like and what they do and with the rules. But you can think about the bigger scales of what Google as an actual product does, what Amazon shipment logistics looks like. And we can think about what big technology and these big software products are looking like and doing. And the design of that is something we're trying to really get at. And so in this section of Poieto, we want to think about our own ways of looking at the technology and getting critical about it. 11. Oh, sorry, this slide. In this section, you can take existing frames or different lenses or different approaches that other people have brought up or create your own. And so this one that's highlighted is called systemic oppression. And so we can think about how systemic oppression in this example could be a contributing lens to analyzing this technology. But next slide. I think one part that is the coolest part about Poieto is that once we've gone through the making and the critical analysis of existing projects or new projects, is that all of the data that and all of the contributed information is something that, if you like, can be used for Poieto and for other projects and for other people to use. And this is where we as individuals can start taking our data in our projects and start putting them towards a community database, a community pool. And then others can see how others who are new to Poieto or new to these projects can start seeing the social approaches that other people are thinking about and using when analyzing other projects and new projects. Next slide. And the part of this tool that is essential is thinking about how not just how our data can be used, our new data for culturally analyzing AI projects is important, but also seeing how it could be incompatible with other tools. And at the end, we can talk a little bit more about this. Christine can give more input on this. But this is sort of behind all of the cultural analysis, is that what you make can actually work. And what we're going to do right now is take this screenshot, this mock-up that we're showing you today, thinking about the input actions and what kind of rules we want to go into our remixed Game of Life, and go through the Poieto methodology together. And because we're in the workshop, we've created this sort of blueprint slide that is not on this mock-up deck. And we're going to go through some examples. And Sarah has done this before with her own research work in school. And she's going to go through this blueprint of what I explained. Yeah, can you go to the next project? Next page, next slide. Christine? Yeah, right here. So Sarah.
Yep, I can take it from here. Thanks, Stephanie. So
Cool.
here we have an example of how sort of the template poieto can apply to the game of life. So I'm just gonna go through the top part. The purple is sort of, how the game of life would fit into poieto and the different. It's a sort of deconstruction of the technical aspects that you learned in part 1. So for we see here with the first box, the blueprint, there's different scenarios for each box, and then there's different rules that are underneath the scenario. So for the input, for the blueprint, for the input for game of life, based on there's modified cell states that are on or off based on the neighbors. And this is based off of the rules and actions, and there's 4 different rules that I could go into depth in with the frame shifts underneath. And then the output is the patterns that emerge based on the neighbors and rules on the grid. So for John Conway's The Game of Life, the different frame shifts, one is dying from loneliness if there's not enough alive cells, dying from overpopulation if there's too many alive cells, reproduction, and the cells will come back to life if there aren't too many or too few neighbors, and then stasis is when it stays the same. So this is just what you learned earlier, sort of just deconstructed. And then underneath, what you'll be doing later is adding your own social and cultural context, and then your own frame shifts, your own scenarios and rules. And just to make this a bit more clear, I'm gonna go over a few examples of different social and cultural contexts that have been used before using poieto. Next slide, please. So this example is made by a Feminist.AI member, Sarah, and she had her context be about Fijian body ideals. So she writes that with increased access to television and influence on social media, access to depictions of Western beauty ideals has caused Fijian women to desire or pursue the thin ideal. So these rules are based on social influence and peer pressure that are from Fijian body ideals. So the first scenario is that there's not much influence and the cell dies if it has less than 3 neighbors or influences. The second scenario is that there's peer pressure. The cell dies unless it has 4 or 5 neighbors. And then the last scenario is overwhelmed, and the cell will die if it has more than 8 neighbors or influences. Next slide, please. So this video is what the code looks like when you run it using Sarah's rules that she developed from Fijian body ideals. So here we can sort of see poieto in action and how the code visualizes the social and cultural context that Sarah outlined as a frame shift. And it's really cool to see how like the blooming black spots from the code correlates with the visual imagery of how these beauty ideals can take root and spread in our minds. Yeah, so you can see it slowly blooming. And the rate of which the cells move can be manipulated as well through the code. All right, thanks for playing that. I think it's a clear picture. Next slide. All right, so here's another example from Odie, who's another CalArts student. They made their rules based on how people with social anxiety function at social events. So the rules depend on how many people they know. So their first scenario or first frame shift is that they won't go, which means that the cells will die if it has no neighbors, that they'll get stressed, and so the cells will die if it has 2 or 4 neighbors. Another scenario, again, stressed if there are more than 5 neighbors, so the cell will die off. But then there's also the last scenario of feeling comfortable if they know like 3 people at the party, which correlates with here living, the cell lives if there are 3 neighbors. And actually, just to clarify that, let me just read what Odie had written on their project page. So they wrote, if I don't know anyone at the party, I probably won't go. So that correlates with the cells dying if it has no neighbors. If I know either 2 or 4 people at the party, I don't know how to divide my time and get stressed. That correlates with the cell dying if it has 2 or 4 neighbors. If there are more than 5 people I know at the party, I get stressed out and leave. That correlates with the cells dying if there are more than 5 neighbors. And then if there are 3 people I know at the party, I feel comfortable and stay for a while. And that correlates with the cell living if there are 3 neighbors. So I hope that's a bit more clear. It's very conceptual and abstract. Next slide, please. So this video shows the code again in action. And it shows like the flickering green and black from the rules actually ends up creating sort of a visual representation of social anxiety. And you can see like compared to the last one, this is flickering at a lot more of like a faster rate. Next slide, please. Okay, so this is an example that I made about COVID-19. So this applies to myself, but it can apply to others as well. So under COVID-19, my concept was under COVID-19, social distancing has been enforced as a way to mitigate the pandemic spread. These rules are based on whether or not people distance themselves in the presence of others. So my first scenario is that I feel safe if there are less than 2 people near me. So this correlates with the cells living if there are less than 2 neighbors. And then I'll feel unsafe if there are 2 or 3 people around me that I don't know. So the cells will die off if there are 2 or 3 neighbors. And then for me, I have a family of 4, so that's why I said that I'd feel comfortable if there were 4 family members near me. So this correlates with the rules with the cells living if there are 4 neighbors. And then lastly, I would stay home if there are more than 5 people near me. And this correlates with the cells dying if there are more than 5 neighbors. Next slide, please. So now it's your turn to apply your own social and cultural context to Poieto. So here's a blank template that you are going to use where you can fill in your own social and cultural context, like those 3 other examples I showed, and then also with your 3 to 4 frame shifts. And you can see at the top, you can fill in your name and email. So I don't know if the link has been put in the chat yet, but there's a link to a slide deck with the blank templates, and you can start working on your own. And if you want to share the results, please email us. I don't have the email address right now, but if you can email us with your consent to be able to share this and like share your scenario, that'd be cool. But yeah, we'll just give maybe like 10-15 minutes for you all to play around. Oh, let me go over the instructions actually in the next slide. Thanks. All right. So I want you all to think about the states of your cell and your neighbors. What is your metaphor? How are our own real life social conditions informed by those of our neighbors? And how can differences in our data change your understanding of an experience? And you can also think about other prompts, other questions, and think about what else you'd like to consider when creating your own example. Next slide. Yeah, so this is just some independent playtime.
I also will just pick up saying that another thing to think about is when Sarah did a great job in showing us the COVID-19 example that was for her and her own rules. I liked how she thought of it in the context of how one of the rules was she would like to be surrounded by a family of 4 because she has a family of 4 at home. So that personalization is part of this process. And so that's why the rules are really up for grabs, and can really come from different places. If it comes from your own personal experience, that also is quite interesting in thinking about how the technical has a social component. So, and I don't know how long we'll keep you guys, but take maybe, looking at the clock, take as long as you want. But then we'll share, hopefully, some of your projects.